In this video, we'll be covering the graphs of sine and cos with a focus on amplitude and period. The amplitude is how high or how low the sine or cos graph fluctuates. And so the concepts associated with the amplitude will be the mean, the maximum, and the minimum. And the amplitude helps you define what the range is of the graph. The second concept that we'll be looking at is the period. And we have an equation there where P equals 2 pi over n. And we'll look at breaking up the graph into quarter increments, into 4 pieces. And this will help us investigate what the domain is. So again, we have the basic graphs there of sine and cos. But when I draw up the graph this time, we'll draw it up a bit differently. When we look at the amplitude of a graph, we need to look at the mean line first. Now the mean line is usually 0 because we don't have a vertical translation there where we're adding a particular number or subtracting a particular number. We'll look at this later on when we do transformations of sine and cos. So usually we have the mean line, which begins at a value of 0. But from there, the amplitude will go up and down to our max line and our minimum line. Now these amounts here will be equal, so we want to space them out in between nicely, like so. Now, when we investigate what the amplitude is, we look at a particular area of the equation. This here is the number that's represented at the front of the sine. In other words, it's the same as the dilation from the x-axis. In this case here, our amplitude is 1, which means that we go up by 1 and we also go down by 1. So our maximum line therefore becomes 1, our minimum line becomes -1. So that covers the idea of the amplitude. So therefore our amplitude A is equal to 1. I might pop this up here so we can see it more clearly. The second concept that we're going to look at is the period. Now it's 2 pi on n. What is our n value? Our n value is defined by the number in front of the x inside the bracket. So in this case here, our n is equal to 1, and we will need to run a little calculation where the period is equal to 2 pi over n, make the substitution where n is equal to 1, and so therefore our period is 2 pi. Now recognize that our graph is a sine graph, so let's draw up the sine graph. Remember, for the unit circle, the sine graph starts at a default value of 0. And when we rotate around the unit circle, our y value goes up, goes back down, all the way down, and back to the top. This is one entire period, or one entire cycle. For this particular graph here, we are starting at 0. Now, always start at 0 for any basic graph that you're drawing. Our endpoint here ends at a value of 2 pi. Now I will introduce the concept of quarter increments, which will help you sketch more complicated graphs later on. So to find our quarter increments, we're going to split this period in half and tag that by dividing 2 pi, or our period, by 2, which ends up at pi. Now, dividing by 2 is the exact same idea as multiplying by 1/2, or multiplying the denominator by 2. So if we split this in half again, we'll end up at pi on 2. And then for our third increment, we just need to count or multiply this first increment by 3, which gives us a value of 3 pi on 2. and this will work every single time. Now, to go over to the cos graph, we will do the same thing. Let's do this a bit more quickly now, since we have a gist of it. For our amplitude, we investigate the number in front of the cos. By default, there is a 1 there for it to exist. And then our n value to find our period is 1. So therefore our period is equal to 2 pi on n. So therefore we end up with 2 pi over 1, which equals to 2 pi. Let's draw up our mean line. We have a mean line of 0. And because our amplitude is 1, our maximum line will be positive 1. Let me draw those lines again. Positive 1. And our minimum line will also go down by 1 as well to negative 1. Our graph for cos usually starts at the top by default. Then we will go down to the mean line, down to the minimum line, back up to the mean line, and back up to the maximum to come full circle. Since our period is 2 pi, we're starting at an x value of 0, and the end of our period, or the entire cycle there, is 2 pi. Break it in half, split it in half again, then multiply by 3 for our third increment. Now in the next segment of this video, we'll be exploring what happens to our amplitude and our period and our basic graph here when the amplitude and the period is not equal to 1.